Okay, we left with talking about concentric and eccentric isotonic contractions and then isometric contractions where the length of the muscle does not change. All right, there are fast and slow twitch muscle fibers. The big takeaways are the contraction speed. Now, they can be oxidative, um, using respiration or glycotically, uh, which is part of the respiration, but that's not important for you. There are three types of muscle fibers found in humans, and all of these contain combinations of fast and slow twitch fibers. So type 1 is called a slow twitch fibers. And what you want to start here is it's resistant to fatigue. Sometimes they call them red fibers because they have a lot of myoglobin in them and a good blood supply. There's a lot of mitochondria and they are slow to contract. Your fast twitch fibers, type 2, so both of these are white fibers, and while type A is resistant to fatigue, type 2 is susceptible to fatigue. They both they both can make ATP very quickly, and they contract rapidly. So hypertrophy is when you enlarge skeletal muscle because you exercise it. Atrophy is one you'll see more often is a decrease in size. And so I think about my mother, her past few years of life, she really sat on the couch and watched TV all the time, and her muscles atrophied. And eventually she didn't have the strength to move. And remember, I told you, you have to move to stay alive. So aerobic exercise stimulates the slow twitch fibers. In response, those fibers increase their capillaries and their mitochondria. Forceful exercises stimulate mainly your fast twitch fibers, and they produce new actin and myosin filaments and get enlarged. A bit contrary to what a lot of people say, you don't break down muscle cells or muscle fibers. You are actually breaking the myofibrils, and they're reacting by creating more than they had, and that makes the actual muscle cell fatter, and then the tissues fatter, and of course the muscle as a whole enlarges. So let's just briefly talk about smooth muscle, and then we'll talk about cardiac muscle and start naming our muscles. So compared to skeletal muscle, smooth muscle fibers are shorter. We learned skeletal muscles are very long. They only have one nucleus, where skeletal muscle fibers have many. They have these tapered ends. Their myofilaments are randomly organized, unlike the skeletal muscle. They don't have those striations. They don't have T-tubules, and they don't have a well-developed SR. All right, so there are multi-unit smooth muscles, and they function as separate units. So that's why they're called multi-units. The iris of the eye, the walls of your blood vessel, they are stimulated by both neurons and hormones. But visceral smooth muscle are single unit, meaning the cells all respond as one unit, and these are found in sheets. And they are the most common type of smooth muscle, so you want to star these. They conduct in peristalsis, they exhibit rhythmicity, they're all kind of like working together, and they're held together by gap junctions so that they can work as one large unit. Let's see. Smooth muscle resembles skeleton muscle because it does have actin and myosin. It uses calcium ATP, and it's triggered by some impulse. The difference is that smooth muscle does not have troponin. It uses a different protein instead. There's two neurotransmitters that can affect smooth muscle: acetylcholine, like our skeletal, but also norepinephrine. Hormones can inhibit or stimulate the muscle contraction of a smooth muscle. Stretching actually can trigger a contraction. They're slower to contract and relax. We kind of knew that. They are more resistant to fatigue, and they can change length without changing the tautness. Now, cardiac muscle is, we know, located in the heart, is striated, has these intercalated discs. The fibers are branched, and they only have one nucleus. The networks of fibers do contract as a whole unit so that you have this synctition, right? Remember the atrial can systole, and then the ventricles can systole at the kind of in a rhythm. They are self-exciting. That's different. They have a longer refractory period than skeletal muscle, and they don't have tetanus. So here are some characteristics of muscle tissues, skeletal, smooth, and cardiac, and where they're found, their mode of control, some characteristics. So let's look. Skeletal muscle generate many types of body movements, and this is where we want to get into really understanding how this works. So bodies use levers, and so we use a rod, a fulcrum, resistance, and force. And while this is interesting when you look at the physics of it, I'm not testing you on this, so you can put an X on this particular slide and the next one. And this one even, it's talking about what's the fulcrum, what's the force, what's the resistance. Not going to test you on that. But here is a star. You do want to know origin and insertion. We've already mentioned this when we talked about bones, that the muscle is attached to the less movable origin bone and inserted at the bone that will move towards the origin. So here you should have to label this on a practice. I believe it's also on a test. So you might know that this process here is where the tendon is binding the long head of the bicep, and the short head of the bicep tendon is here, and here's the long, you can see it's longer. And so this is the origin, and this is the insertion. And so when this muscle gets shorter, it pulls the insertion towards the origin. And what is it inserted on? The radius. So a few muscle functions and how they interact with one another. You do need to know this. The agonist is the muscle that is causing the action. It is also called the prime mover. So these are kind of the same thing. A synergist is any muscle groups that help the prime mover. For example, we'll see like closing our jaw. The masseter is the prime mover, but your temporalis muscle is a synergist. And then an antagonist is the muscle, like in a story, the antagonist goes against the agonist. So it causes the opposite direction. So if your bicep is the prime mover, the tricep would be the antagonist, working against it, controlling that movement. Okay, so here are muscles that you need to know. The ones I mentioned, which probably most in this picture you do need to know. So trapezius, serratus anterior, think about a serrated knife. It looks kind of like a serrated knife. It's going to be right here, coming out of the axial area. External oblique. Oblique means at an angle, and these are the external muscles that make your sides. Rectus, straight up and down. Abdominis, so these striations run up and down. Tensor fascia latae is latae for lateral side, and so this is this small muscle right here of the hip. Sartorius is your longest muscle, also called the Taylor's muscle, because it goes all the way from the hip to the knee. Rectus femoris rectus, again, like rectus abdominis means straight, but here it runs straight on the femur. Adductor Remember what adduction means, to move the muscle towards the body. So that's going to be on this inside. When it contracts, it pulls the leg to the midline. Vastus large lateralis is to the side of the rectus femoris. So here's rectus femoris. Here's this large muscle to the laterus, to the side of rectus femoris. Fibularis longus runs along the fibula, and it's very long. Tibius is anterior, running along the tibia. And extensor digitoris longum helps move these digits. Dorsal flexion, pretty much. Okay, let's go on this side. Frontalis raises your eyebrows. Orbicularis oculi, around the eye. Orbicularis meaning orbit, go around. Oculi is eye, so this helps with winking or blinking. Zygomaticus should sound familiar, along your cheekbone, and that's going to help smile. The masseter, you can't see well here. We'll see it closer up in a little bit. That's going to help you draw your jaw up as you chew. Orbicularis, again, around oris is mouth. So this helps you do the kissy face. My favorite muscle, the sternocleidomastoid, runs from the mastoid process of the temporal bone to the sternum and the clavicle. So sternum and clavicle and mastoid. This helps you flex your head. Your deltoid, when you shorten this muscle, it will bring the arm up. So that would be an abductor of the arm. Pectoralis major muscles of the pecs. Bicep brachii, we saw, has a two-headed muscle, which is why it's called bicep, and brachii of the arm. And so when you contract this, it extends the elbow joint. Flexes the elbow joint. Brachialis runs right along the bicep brachii. Brachioradialis is the forearm. Gracilis are another group of adductor muscles of the leg. We had vastus lateralis. It was the large muscle to the side of the rectus femoris. Well, medial to the rectus femoris is vastus medialis. Your gastrocnemius is part of your calf, and the soleus is a large part of the calf. Let's look at the back. So temporalis will be on the sides, a small muscle. It helps you chew. Occipitalis, believe it or not, is a synergist for your temporalis. It helps you raise your eyebrows. Here's those traps. Notice that it's named after it being a trapezoid. There's the delts we saw. Teres major and minor are back here. I usually don't test those, so you don't have to worry about that. Triceps, a three-headed muscle, brachii. When you contract this, it does extension of the elbow joint. So it is the antagonist of the biceps. Okay, biceps, not brachii, but femoris. So think about what biceps does to your arm. It bends the elbow joint. Well, bicep femoris bends the knee joint. So it's going to be in the back of the leg. Sembitendinosus is a long muscle that helps the bicep femoris. And semimembranous muscle lies deeper to those. There's that gastrocnemius, and here's a tendon that binds it to the calcaneus bone. I don't test on this. Latissimus dorsi is a large muscle of the back. There's your external obliques that were the sides that run to the front. Your gluteus maximus is here, gluteus medius here. So a larger muscle and a medium muscle. There's adductors that help move the leg in, along with the gracilis. Vastus lateralis running on the side. Sartorius, hard to see, that long muscle. Fibularis longus is running on the edge, and then soleus is deep to the gastrocnemius. So here are the muscles of the face and where their origin is, where their insertion is, and what they do. They're all innervated by the facial nerve because they're on your face. So, we haven't seen these yet, but there's epicranius, orbicularis oculi, and oris. We saw those. Buccinator is going to help you compress your cheeks in, so suck them in. Zygomaticus, we don't differentiate between major and minor, but they help you smile. And then their platysma is this curtain of muscle that goes over your neck, and it depresses your lower lip when you're pouting. Also, when you're breathing, taking a deep breath. Remember your masseter, I said elevates your mandible, helps your jaw close. It's a prime mover for chewing. Temporalis helps the masseter. And then we don't do these. So here are where these are located. So temporalis over the temporal bone, frontalis over the frontal bone, occipitalis back here that helps, believe it or not, raise your eyebrows. There's orbicularis oculi, orbicularis oris. Here are your zygomaticus that help you smile. Here's that huge masseter for jaw closure, very, very strong muscle. Clamp your teeth together, you're using that. You can feel it when you're chewing gum. Sometimes you can see it. Here's that buccinator, so when that contracts, it sucks your cheeks in. There's the sternocleidomastoid, and then this drape, the platysma that helps you frown. You can like strain it, and you can kind of see it under your neck, and then your trap back here. TMJ is a problem of the mandibular condyle and the mandibular fossa of your temporal bone. So you can feel it right in front of your cheeks. It's caused by a misaligned jaw due to grinding and clenching of the teeth. This is the more common reason. And it causes a clicking in the jaw and can be painful. My son has this, and eating popcorn and chewing gum don't help. So there is some physical therapy to help, but it doesn't really bother him as much anymore. Muscles that move the head and the vertebral column that you need to know, of course, sternocleidomastoid, and that's all on those. And none of those. Muscles that move the head, vertebral column, and I don't think any of those. So these are all deep muscles. Don't X this. You won't ever see that. Do need to know about trapezius. This serratus anterior, pectoralis, not minor per se, but levator, think about an elevator, brings it up. Scapulae, this elevates the scapula. This is the shapes, size, shape. It's kind of nice that they name muscles, either where they're located, how many heads they have, what they do, their shape, all kinds of things. Do need to know deltoid, do need to know latissimus dorsi, do need to know your traps, and none of those. Pectoralis major, latissimus dorsi, deltoids. So deltoids, pecs. Here's the pecs minors. They're deeper to the pec majors. Rectus abdominis. Now there is transverse abdominis, so it's the deep abdominal muscles, and notice they're running transversely, and then you have internal obliques that run at an angle and external obliques. This linea alba is the line of connective tissue that separates the left and right rectus abdominis. There's that serratus anterior. So see how it looks like a jagged edged knife? Don't worry about these. You do need to know biceps brachii, brachialis, brachioradialis, tricep brachii, and that's it. So traps, delts, bicep brachii, brachioradialis, deeper than the bicep brachii. Let's see. I think you need to know a few of these that move the hand. They kind of tell you what they do and where their origin and insertion is. So there's our brachialis and brachioradialis right here along the radius bone. If you're going to bend, if you're going to be a flexor and bend these digits, you would be on the anterior side of the arm. If you're going to extend those digits, you would be on the posterior side of the arm. So that's why they call them extensors on the posterior side and flexors on the anterior side. In anatomical position, don't need to know this cross section. External oblique, internal oblique, transverse, and rectus all are good to go. We've seen them a few times. Rectus, internal oblique, external oblique, they go at opposite angles, and then transversus abdominis runs lengthways instead of up and down. We are not studying the muscles of the pelvic floor and perineum, so you can X out all these, or that muscle. Muscles that move your thigh, gluteus maximus, medius. There is minimus, but you won't have to note it. Hip flexors, iliopsoas. Important to me because I've pulled these muscles before, but you will not be responsible for them. Adductor longus, gracilis. So there's that gracilis, that adductor. There's vastus sartorius, rectus femoris, vastus lateralis, vastus medialis. This is a good picture of the media, gluteus medius and gluteus maximus, bicep femoral. Think about that. When that contracts and gets shorter, it pulls that leg bent, flexing the knee. Here's your IT band. Runners have troubles with that. Ouch! I've ran a marathon and wasn't able to train correctly because of my iliopsoas being messed up. So I hurt my IT band and couldn't walk for about 2 months. Here's that vastus lateralis running right to the side of rectus femoris, and then there's that sartorius, that Taylor's muscle, and tensor fascia latae, that hip. So muscles that move the leg, bicep femoris, semitendinosus, semimembranous are your hamstrings. So we've seen the sartorius, which is that very long muscle of the leg, and then your quads are your rectus femoris with the vastus lateralis medialis, and then we're not looking at intermedius. So here are the quads, semitendinosus, bicep femoris, semimembranous. And then you see your sartorius kind of poking out there. There's the calf muscle, the gastrocnemius. Don't need to do a cross section through a thigh. But somebody said in class, that looks like steak. Well, any meat that you're eating is muscle, so it should look like steak. And then muscles that move the foot, tibialis anterior, so running along the tibia in the front. Gastrocnemius does plantar flexion and flexes the knee. And so it's just reviewing those that I said you needed to know. Again, no, don't need to know the cross section. So as you get older, myoglobin, ATP, and creatine all decline, probably around your 40s, and adipose starts to replace some of that muscle tissue. By 80, almost half your muscle mass has atrophied. So how do you keep that from happening? Exercise. And that is the end of this unit. Congratulations. Don't forget, this is now the time to do those 3 labs and that very long practice worth a lot of points before you do your test. You can do your practice more than once. In fact, I encourage you to, so you see more questions, maybe get a better grade, and better prepare for the test. Good luck.